Hello everybody, welcome to the topic of quadratic functions. I'll be telling you this. At the Canadian celebration, a firework is projected vertically into the air and reaches a maximum height of 100 meters. The path of the firework is parabolic and it lands 30 meters from the launch site. Determine the equation. When they say determine the equation, they're actually talking in vertex form. And I'm assuming if you watching this video, you know what the formula of the vertex form is. So if we actually look at the key details and underline them, you can say vertically is a key point. It's projected vertically, so it's like if you were to draw a graph, it would actually be y. Reaches a maximum height of 100 meters. Now, maximum can mean two things, like, the top height, but it also tells you that the parabola is going to be opening downwards. So that's a good thing to know. The path of the firework is parabolic, which means it's like it goes up, reaches at one point, and goes down. And it lands 30 meters from the launch site. So if we say the launch site is like 0 meters, the projectile traveled 30 meters away from its original position. So if we're like gonna say we're gonna draw this in a graph, can we actually make the thing thicker? In a graph, we can just say this is of course the x coordinate, and this is the y coordinate. Now let me try drawing a parabola. So, oh my god, excuse my drawing. Oh jeez. 0 reaches the maximum height and ends here. This is x. So here's our badly drawn parabola. Now if we actually look at the key details that they give us, let's start. The projectile is launched vertically into the air, so up, down, blah blah blah, and reaches a maximum height of 100 meters. So that means this point right here, which is its maximum height, is 100 meters. 100. So that means we can actually draw a coordinate for this as, in terms of the graph, something 100, something comma 100. The something is going to be the x, which we still don't know yet for this case, but we can easily find that out. And it says the thing is parabolic, so the thing is shot up and then goes down, and it lands 30 meters from its original launch site. So that means, like, this is the original launch site, this is the point 0, 0, or the origin, and here is the point where it falls or finishes its parabolic trajectory, and this is 30 meters away from the launch site. Okay, so we have some key detail right here. If this is like this, in terms of the graph, we can actually find this x coordinate right here, using this 30, because what's half of 30? Well, half of 30 is 15, which is the middle, which would match up with the maximum height of the launch. So that means this here is 15 meters. So that means this place, the coordinates of this is 15, 100. Okay? If that made sense, you just divide by 2, get the halfway point, blah blah blah. 15, 100. So we have some stuff that we can work with here. Using the equation, the vertex form is, let me choose a different color. Vertex form, to be, shit, sorry. The vertex form, it's y equals a bracket x minus p whole squared plus q. Now, in this case, the p-value is the x coordinates, and the q value is the y coordinate. Now here you have two x's and y's, like y equals a, and then you have the x minus p. The p and q value are the coordinates, are the numbers for the vertex coordinate. The vertex is the maximum height, so this is the middle of the parabola. You can split this and say the axis of symmetry is 15, x equals 15. Using that information, we can actually just start plugging in numbers already. So, oops, let's make that. Okay, so let's say y equals, I don't think you guys can see that. Let's make this white. Y equals a x minus p whole squared plus q. Now, you can actually plug in y in this case. You can't use the vertex y twice. You're going to be using the 100 down here because q value is the y coordinate of the parabola. But you can use the origin. So 0, 0. So you can actually just put 0 equals a bracket x. So again, you can use this coordinate. But you could use these coordinates if you wanted, but it's easier to use the 0, 0. So, because the 15 is going to be going into the p, because the p value is the x coordinate for the vertex. P and q values are the numbers for the vertex coordinates. So, 0 minus p, which is 15, bracket, whole square that plus 100, which is the y value, the 100 meters that it goes up by. So if we evaluate this is going to be 0 minus 15 is negative 15. Square that, it's 225 times the a, which is 225a plus 100. And from here it's simple algebra, subtract 100, that equals 225a. And in this case you would get a fraction, negative 100 over 225, which you can also write as negative 4/9 equals a. Okay, so here it's going to be our final product. You have your a value, you have your a value, you have all your stuff. So we can write like the finishing product right here. So we're just going to say, for Pete's sake, y equals a, which is negative 4/9, bracket x minus p value, which is 15 for the vertex coordinate, squared plus 100, which is the q value. So this is our final equation for this problem. So this is solved. There are two other parts, but I'm just gonna cover that in the next part of this video. The two other parts of that go with the this problem. They're fairly simple, much simpler than this. But I hope you guys learned something from this. Please leave a comment if you did. So thank you for watching.